guys, welcome to our channel of Sciences and Mathematics. Today we are going to name also, it's a practice exercise. We are also going to name the molecules that we have listed on the board and try to identify which class of our organic compounds they fall into. So in this case, as normal, we're going to list some of the characteristics, of course, of this molecule that we have listed and try to apply some specific rules that we have learned in naming other organic molecules in order to identify which category or class of organic compounds they fall. So in that case, of course, I'm going to list this as a compound. And this is our characteristics that we can be able to identify. And perhaps this is going to be our conclusion on which molecule, or maybe the nomenclature. And then that is going to give us a conclusion on which kind of molecule it is and which class of organic compounds it belongs to. So in this case, I'll just start with the first one, whereby we're going to look at which functional groups appear, or which functional group appear in this particular molecule. So if you can try to look at this kind of a molecule, you can see that there's a functional group that is appearing at this specific point, which is this, which of course appears like that, whereby this methyl, of course, we can just designate R prime as a methyl group, and then we have got this other side, which we can be able to just indicate by using a different color coding, perhaps, which is this one. Now this one forms R, while the other one forms what you state as R prime. No, the all of actually the all of this molecule forms this functional group. I can just designate this one. Okay, this is R prime. That is okay. This is a functional group. For the methyl one, I'm just going to indicate it using a different one, which is this is R prime. Okay, that's right now. This segment for head is for a functional group that we have identified, and then number 2, this other one represents the R that I've written, which is this one. So therefore, from that configuration or of structure, we can be able to identify this as an ester. Ester, which is a combination, of course, maybe a product of carboxylic acids, carboxylic acids and alcohols. So in this case, we are going to try and list some of the characteristics. So therefore, we have identified this one and this an ester functional group. And then number 2, there are other substituents that, of course, we can identify from this group. And in this case, the numbering starts from this carbonyl carbon for the functional group. So therefore, we can count this one, 1, 2, 3. So this is a three-member carbon. So therefore, we're going to discriminate it using the propane from the alkane series. So that is where it is going to do its parent name from. And then we shall look at another characteristic. Of course, we have said that there's a bromine, bromo substituents at this specific point. That's at carbon number 2. And then number 3, we talked about the concept of projection when we were trying to talk about or maybe configurations for molecules in 3-dimension, when we were trying to talk about the Kern-Ingold-Prelog system. So this molecule, of course, I'm just going to list it and then we just explain maybe later in some of our videos why. But we are given the name rectors to represent right. So therefore, it's going to give a designation for that, which is R. So therefore, trying to find a name for that, we'll start by listing the constituents, and then we give a designation for the configuration of this molecule that we have listed as rectors, which is blind right. And then we shall have the position of the bromo group concluded by the parent name. Now there's a characteristic ending for the esters, whereby we substitute part of the ic. Remember, for the carboxylic acid, we end the name with ethanol. If it's a second member ethanoic acid. So in this case, if it's an ester, then it's going to form from the alkylate group, it's going to form ethanoate. So therefore, if you compare the two names, we're going to see that the name, the suffix is going to end by using that name ate. So if it's ethanol, ethanoate, propane, propanoate from the alkoxide group. So we are going to have this name as methyl. This is methyl rectus, that is folate, bromo, three-member carbon group, propanoate. Now I've specifically tried to just use that one in a nutshell, now that we have a video for discussion for that, so that of course we're able to learn about other, like the Fischer projections and also the molecules that can be able to be identified. Suppose we have this plane, this both are plain our paper. There are some molecules which will be appearing on that other side, while others will be appearing on this side, and some will just appear on the plane, along the plane of course of this particular board. So we are going to have different designations for these kind of molecules in order to show which molecule is appearing, or maybe which molecule is appearing at a specific point. It's just going to have a tetrahedral structure. I'm just going to have it this way. Maybe I can just have it that way. As you can see, for the three molecules, of course, there are different ways in which they are being represented. And we're going to see that each of the symbols that is used to represent this kind of a molecule bears a significance. So that's where the concept of this one comes from. And we're going to see that one in details on the topic of discussion. Of course, I'm going to put a link to the video on the above, on the what I've just mentioned, and then we'll be able to be okay with that. So for the second molecule, we can be able to identify the characteristics. And this first, there's a cyclo, which is a 1, 2, 3, 4, 5 member carbon. Of course, that's a pentane. So for a substituent, it's going to be a pentyl. And then we have a functional group, of course, which is an R, O, C, and then there's an I there. So basically that's an ester as well. So therefore it's an ester. And then we have got substituents at point number . So if we are doing the counting, then we will just start from the carbonyl carbon, and then we shall have a methyl substituent at point number 2. So if we go this direction, then it's still the methyl group is going to be at point carbon at this particular carbon, which is this one. This is the carbon that we are doing reference. So it's supposed to be 1, 2, 3. 1, 2, 3. So therefore, we just, in any case, we are going to have a substituent at that particular point. And then for that one, it's going to be a 3-member carbon, that is propane. And then next, what do we identify? We have said about the molecule, the methyl. So we are just going to go ahead and do the naming. So we start with the name this is a pentyl group, so this cyclopentyl position of the substituent 2-methyl, and then we have a parent name, 3-member carbon, propan, no-ate, propanoate, cyclopentyl 2-methyl propanoate. So this as well is an esters, we have said. Therefore, we are going to have esters named by first identifying the alkyl group and then the carboxylic acid, by replacing oic by the name 8, as I said, because from our first example, this is the suffix that is going to replace the name oic with 8 from the carboxylic acid. Now this is produced, of course, these are the esters which are produced through the reaction of alcohols and carboxylic acids. And we are going to see that, of course, there's a general representation for that, but we're going to see that one under the reactions of either alcohols or carboxylic acid. But generally, the naming is done by combining the radical name of the alcohol with that of a negative ion of the acid, whereby the alkyl name comes comes first, followed by the name of the carboxylate ion. So generally, maybe I'm just going to give an illustration of what we have, the general format that is just being used to end this in this red triangle. So I'm going to have this just for the general representation of a functional group from the carboxylic acid, which is going to combine with the alkyl group from the ethanol. So therefore, if you try to look at these two sections of what I've drawn on the board, we have what we'll call an alkanoate and an alkyl group. We just do that boundary there. So this is an alkyl group, and this is an alkanoate. So generally, what the statement says that we are going to name the ester by starting with this one first, the first one from the alcohol, and then the one from the negative ion of the carboxylic acid. So it's going to be alkanoate. This is the general representation in which we are going to present the naming for identifying this class of organic compounds. Now, these esters are very essential, of course, from our day-to-day operations, in that they are used for production of various alcohols and amides. Amides are other class of organic compounds which are carboxylic acid derivatives, and they are produced by the use of compounds such as esters. Of course, they can be used in this synthesizing flavors, perfumes, and other cosmetics, because of course we have talked about that one of our main topic, basic, that identification of esters, physical ones, is that they have a sweet smell, so, or a flavor, or fruit smell. So in this case, they can be used for manufacture of perfumes, flavors, and other cosmetics. So we shall stop there for today for this topic, guys. I hope that we have been successful in trying to identify the molecules that we have drawn on the board by using some of the specific rules that we have discussed insofar as nomenclature is concerned. So for that case, thank you for today. Bye, God bless.